Okay, so good morning, everybody. For the first talk of this day, we have a talk about Elasticsearch by Mattews, who runs a local Glasgow Python, the local Glasgow Python user group, and he works for Artrix. Sorry. Thank you.
Thanks. Okay, so why am I here talking about Elasticsearch today? So, as you just heard, I'm a senior Python developer for Artrix. I'm living in Glasgow, but they're a London-based company. And yeah, I run the local Python user group. And at Artrix, we do a lot with search. So we have a whole hosted platform around search, and there's a lot of tooling around it. So we've got quite a versatile system to do with lots of data processing and document management. And at the core of that is Elasticsearch. But we have been doing search for quite a few years, so it's not the first search product we've been using. And so what is Elasticsearch? So it's an open source Java project. It's based on it uses the Apache license. It's backed by the Elasticsearch company, which was recently founded, and they got lots of funding. They do sort of quite careful feature development, so there's nothing really rushed in, everything's quite well considered. And the primary author is Shay Bannon. And what I mean by primary author is you just look at the GitHub and you can see there's one insanely productive man, and then there's a lot of other people helping out now, and I think it's a lot more balanced now, but yeah, he's done an incredible amount. So what is Elasticsearch good for? The obvious one is, this isn't a full list, but the obvious one is full text search. So it is a search index. It's based on Lucene. But for me, in some ways, it's more interesting the different uses, the sort of the non-standard uses for search. So you've got to think about it as actually it's really quite a general data tool. So it's also good for big data. Part of the reason for this is it's non-transactional. There's no locking, and in essence, it's kind of like a really big key value store. And I'll show you why in a minute. It's incredibly good at faceting, and what I mean by this, so faceting is it's the way of sort of grouping data in SQL terms. It's a bit like a group by, and it's just amazingly fast at doing this, and it's a lot faster than any sort of relational database, and it's really quite advanced. So you can do sort of aggregations in your faceting, so you can do lots of grouping, and you can really discover and explore your data well with that. And so then geographic information systems is really good for sort of searching location-based searches. And one of the key ones, which is, I guess the main reason why we moved to Elasticsearch, we were using Solr before, is clustering. Elasticsearch has had clustering built in from the ground up. So it's designed for it, it works really well. Yeah, it's just really reliable. Solr had it added in 4.0, which is after we switched, so it was a bit late, but I'm not as experienced with it, but I've had it's not quite as comprehensive for the clustering yet. And finally, logging is quite an interesting one. So this is something that a lot of people are using Elasticsearch for now, is for storing logs. And the reason this is good is because Elasticsearch can hold a lot of data, no problem. So hundreds of millions of sort of Apache log lines or something are no problem, and then you can explore your logs and make use of them. Having several sort of gigabytes of text files typically isn't that useful. Okay, so how does Elasticsearch store your data? It is a document store. In that regard, it's kind of like Mongo, although Mongo uses a binary JSON. And there is JSON everywhere. So everything that you put in is JSON. Every time you speak to it, you're speaking in JSON. And you will speak to it over HTTP. There is also the Thrift protocol, but that's more used by sort of libraries and drivers, I think. That's the Apache Thrift protocol. So yeah, there's some quite nice things there, because then you can use and explore the data with curl or your browser, so you can just hit it. It is a schemaless database, but there's kind of a gotcha here, because it's more like an introspected schema. So the first time you insert a document, it creates a schema based on what you inserted. And I'll sort of explain that more in a bit, but so say you insert a document with body and then the content is just a long string, it's going to say this is a string. If you then do another insert and you try and put an integer in there, you'll get an error, or it'll just be rejected. And finally, the data is broken down into sort of these three things. So you've got, at the top level, you've got an index, then you've got types within your indexes, and then documents. And I'll just show you that on this slide. So this is a very simple diagram. In sort of relational databases speak, you can kind of think of an index as being the database, and then the types being a table, but that's kind of a loose comparison that doesn't quite match up. Oh yeah, and when you're doing searches, you can search across a type, across an index, or you can do a search across all your indexes. Across all the types in an index isn't too bad, but across all of the indexes, if you've got a lot of them, it can be a bit slow. So sort of 5 or so would be fine, but you probably don't want to start searching across, I don't know, 1,000 indexes. Okay. This is OS X instructions because it's the easiest. But if you use Homebrew, you can just install one command, and then it will show you this in the output, and that starts up running. If you're using Linux, then there's the packages are on the Elasticsearch, the website, or you can install from source. It's all very well documented. Yeah, and after all, it's just Java, so it runs anywhere. I'm not very familiar on a Windows install, though. So after I've done those two commands, I've installed it and it's running. Then if I hit the root path, this is what you get. So this is always how you communicate with Elasticsearch. It's always JSON, and curl is a nice way to do it easily in command line. So yeah, one of the nice things about Elasticsearch, well, it's kind of a funny feature, is every time you start up a node, it comes up with a new random name from a selection of, I think it's superhero characters. So this one's Gigantus. Yeah, so that's the root. So how does the sort of the full API look? Well, the full API is huge, so this is kind of a small sample of it. There's kind of a breakdown. This is kind of the spec of it. So you've got the host and the port that you're accessing your instance on. The default for just running it locally is localhost on port 9200. So you'll see that in a lot of my examples. Yeah, and all of these are optional. I mean, if you don't include any, you get the previous one, so that's not very useful. But so you can put in an index, you can put in types, and you can search and perform actions or do something on a particular document across all of them or individually. So the status is sort of a more of a meta one, so that just tells you some information about that index. I just realized I forgot to update the example on this. Never mind. It's just got silly names rather than names that make sense. Yeah, and the mapping then tells you the schema of the index and the types, and then just showing the next one shows you can do it by type if you want. The underscore search is the one you probably use most, because that's the entrance to the search and the entrance to finding your data, and you do all of your faceting on all your querying through that. And then at the bottom there you can see an example of how you do it with 2 indexes. And finally, sorry, at the very bottom, there is how you check your cluster health. This is something that you'll want to monitor a lot. And you'll want to set up alerts for it. Basically, Elasticsearch has got like a traffic lighting system. When your cluster is green, everything's good. When it goes amber, your data's at risk because you don't have multiple copies of everything. So you should be at that point of reshuffling data to move it around. And if it's gone red, then I think you've basically lost something, so you need to start to worry a bit more. Right, so a quick example of how to index something. And it's interesting to note that after installing and starting Elasticsearch, I can run this command. I don't need to do anything else. So I'll break down what's happened here, because it's quite a lot goes on behind the scenes for the first one. So yeah, I do a put request. So so that's just the HTTP request, and I'm doing it to my events index, and I'm doing it to a talk type, and then I'm manually giving it an ID of 123. So you'll notice I've not created an index previously. I've not created a type. So these are all done automatically in the background. This makes Elasticsearch really good for exploring data and finding out a bit more. So looking at the mapping for this, you would see that it's a document with title and then the content is string. Yeah, and then I basically get a sort of a confirmation message back from Elasticsearch, and you can see that I've piped the result through the Python JSON tool module, which if you don't know about is very useful because it just pretty prints JSON on the console. With the document IDs, You can assign them, or you can let Elasticsearch create them for you, but you get these sort of 20-something character sort of GUIDs, and they're pretty ugly. So we tend to find it's better to use the same ID that you've got in your main database, because typically you'd use Elasticsearch with something else. And then also, it means it's a meaningful thing to you, and you don't need to worry about sort of keeping them in sync or having another relation. Okay, so that was me setting and indexing something, and this is how I can then get it back out. And we're not searching yet still. This is just getting it out by specifying the index type and the ID. So this is the point where we're essentially at a key value store. This is our key. Yeah, and at that point, you can just put things in and get things out of Elasticsearch. However, I don't think anyone would really just use it as a key value store. Right. Okay, so searching is quite tricky because all of the examples are huge. The JSON you write for the query DSL can get massive. But first, this is an example of searching with the Lucene syntax. And the difference with this is you put it in as a part of the query string. So this is the one that's got like not is a sort of a keyword in there, and like and so on. I'm not overly familiar with it. But yeah, it's nice if you want to just do something from within the browser or the command line. That's typically when I'd use it. So yeah, as you can see here, we're just doing a search for ID, and I'll get all documents with that ID. It's a bad example, but it's hard to fit anything else in there. Yeah, and you can see a bit of metadata about which shard it's hit, and then you get results back. Obviously, we only have one in this instance. So yeah, I briefly mentioned the query DSL. This is how you access your data primarily. This is the recommended approach. It's the most featureful, and yeah, that's how you want to do it. There are two main types of operations within the queries DSL. So you've got filters and queries. The naming can get a bit confusing when you've got queries within the query DSL. And the main difference is that a filter is fast cached in Boolean. So you want to primarily use that when you can. And actually, sorry, I had a quote here from Eric Rose at Mozilla. He said, "Filter when you can, query when you must," which I think is good advice because it's a lot faster. So yeah, I'm going to move on to an example of the query DSL, and this is sort of one of the sort of smaller examples I could find that actually does something which isn't completely trivial and useless. So I'm not going to go into too much detail because the documentation is huge on the website. There's so many different operations you can do. It would probably be sort of a half-day session to go through the full thing. But yeah, so this is this query here. You can see basically a number of conditions. So I'm saying we must be searching within the year 2011, 2013. We must not be finding the language PHP. We do want to, ideally, it would be tagged with Python and Elasticsearch. So this is me, my search for my talk this year, I guess. Yeah, so I was saying that the documentation for the query DSL is huge. I was trying to represent that. So this is all the operations listed down here, and it goes way off the page. That was as small as I can make it on my browser. So yeah, just head over to the Elasticsearch website if you want to see all of those. Okay, so we'll just quickly step back a second and be like, how does the reverse index in the search work? So say, for example, I've got these 3 documents. They're all quite simple and very short, just for the example. After sort of tokenization and removal of stop words, this is roughly the reverse index, what it would look like. So you can see that the reverse index, rather than being sort of a document ID containing all the words, it's all the words containing all the document IDs that have that word. So you can see quick is in document 1, brown is in 1 and 3, fox in 1 and 3, jumps in 2 and 3, lazy in 2, dog in 2. And I think this is a very high-level overview. It's not in much detail. Again, it's another huge topic. But the interesting thing to know about this is you can start to understand why some of the different queries are more performant or less performant. So when you've got this, you can quite easily see how a Boolean query would work because, okay, I want to find quick and brown. I can see quickly it's in documents 1 and 1 twice, and in document 3 only for brown. So document 1 would be higher ranked. But yeah, it's just trying to get a rough understanding of how the underlying the data model works. The search index works. It's quite useful just to then understand the limitations. Okay, this is this is a very dense slide. So this is the lessons, and if you're new to Elasticsearch, you probably won't run into any of these early on, but it's something you might want to bear in mind as you sort of go further, where you're likely to sort of get gotchas, that kind of thing. So yeah, the indexing is really fast. This is something that's brilliant. We typically can index quite happily at sort of 2,000 documents a second. And more often than not, it's because Elasticsearch is outrunning our Python processes, and we're battling to keep up, essentially. I think as a good rule of thumb, you want probably one Python process per node in your Elasticsearch cluster. And I've got the the next one the wrong way around. But yeah, the bulk indexing is even faster again, and you want to probably bulk load documents at about 5 megabytes worth of documents at a time. This is this is knowledge that was handed down to from Shay Bannon to one of my colleagues, and then we've had quite a lot of success with it. And I was saying earlier that you probably want to use another canonical storage for your data. This is to make yourself sort of flexible and agile, I guess, more than anything. We've had some sort of stability problems with Elasticsearch. There can be sort of things like out-of-memory errors. They're a bit of a problem. So typically what I would recommend you do is you store your documents in another database, which could be whatever you fancy. We're using either a combination of MySQL and MongoDB, typically. And then you want to sort of have a synchronization process that keeps them up to date, or if your data set is small enough, it's nice to be able to just drop your search index and then just recreate it, because then it's just really flexible. I mean, if you've only got several thousand documents, you can do that in less than a minute. Okay. Another thing that's really important is to run the latest version of Java, and you really want to use the Oracle's Java. This is the one they primarily test against. And by latest version, we were told that you really want to go by the latest point release, because there's a lot of bug fixes which make things better in Elasticsearch and Lucene. I think Lucene is actually used as one of the official test cases for Java, so Lucene will always be working for them to actually have released it. And I mentioned earlier that you want to define your schema. So this is just a gotcha. I personally find this with all schemaless or relaxed schema databases. It's something you just kind of push away the problem and think about it later. It's great for prototyping and exploring your data, but at some point you want to define it, otherwise you just have to deal with it in application code, and that logic can just become a nightmare. Yeah, so the out of memories can be a bit of an issue. This is, it's quite hard to track down basically, but depending on what you're doing with Elasticsearch, you can have quite a different memory profile. The biggest one we found is facets can use a lot of memory. So in one of our largest clusters, we have around about 2 terabytes of data, and the queries per second isn't particularly huge, but the complex queries they do, they go into a incredible amount of detail because they're looking for very specific things within this data. This is a problem we're helping them solve. And it seems to be the more facets they're using, the higher the data is. And also you want to make sure you limit what people can facet on. So it's kind of obvious in a way, but the facets have to be loaded into memory for them to be calculated. But if you try and facet by, say, a large text field, so it makes no sense that if you facet by the content of an article, then you're likely to crash your cluster. Okay, so the IDs of documents, I said before that we always manually set them. This would just surprise me a little. It makes sense when you think about it after, but if you use custom routing in Elasticsearch, which basically means you designate which part of the cluster it's going to, the IDs are not always unique. So if you change something in that document and then it goes to the other cluster, it will never be removed to the other one. We ran into this because we have some documents which are separated by the language that they're in, which makes it a bit easier for assigning specific analyzers and so on to different languages. But yeah, then a document was put in the wrong language, it was corrected, and then suddenly we had it twice with the same ID in 2 different nodes. Sorry. Oh yeah, so writing Java plugins can sometimes seem like a good idea if you want to extend Elasticsearch a bit. However, they are very hard to keep relevant. Elasticsearch has a very stable external API, but internally they always seem to be refactoring and improving things. So you've got to be kind of on your toes, and then suddenly you'll find Lucene is upgraded to version 4, and you've got to relearn all that as well. And then the final one is it's about rivers. So a river in Elasticsearch is it's a way of getting data into Elasticsearch. So you can hook it up to something like RabbitMQ, and everything that's pushed onto that queue will then be fanned out. Will then be sent into your cluster. This is actually exactly what we do. However, there's a risk that the river can overload a particular node because it's not distributed through the cluster. It kind of breaks the clustering model slightly. And I think if you have a problem with that node, the river isn't automatically moved over to another. Okay. One of the great things about Elasticsearch is the third-party sort of projects or code you can have. I don't really have time to go into these, but these are great sort of name drops. The top 3, head, paradigmic, and segmentation side, they are sort of web UIs, and Kibana's a logging platform. So you use it with Elasticsearch and Logstash, and it's good for sort of analyzing and storing logs. Head is just a generic web UI to see what's going on in your cluster. Paramedic is more for inspecting the state and finding problems. And segmentation supply helps you see what's going on in Lucene under the hood, so you can see the segmentations moving around when it goes a bit beyond my understanding of Lucene, but there's quite an expensive operation where it has to merge partial indexes and indexes when they get to a certain size, and this can be quite a performance hit. Okay, so with Python integration, these are the four main libraries that I know of. So there's PyES, which has been around for a while. It's got a slightly odd API. It tries to change everything into sort of classes and objects within Python, and it just feels somewhat, it just doesn't work. It's not very fluid. There is a sort of a newer one, which is PyElasticSearch. It's actually supported by some of the people at Mozilla. They use it quite a lot, and it's used by the bottom 2 as well, I think. It's a much lower level API, so you're typically working with with native Python objects like dictionaries, and then it's converted to JSON on the fly for you. So you kind of just feel like you're working with the JSON API. This does have the downside that your queries in your editor will get very long, but it's much clearer, and it's quite nice once you get used to it. Elastic Utils then adds a more sort of ORM-y type approach on top of PyElasticSearch, which then adds back some of what is in PyES. And when I say ORM-y, I mean it's not an ORM because it's the wrong type of thing, but it feels a bit like sort of Django's ORM or something like that. And then finally, Django Haystack is very easy integration with Django, and it's really nice if you just want to keep going quickly and hook up with your Django models. It's also got the added benefit that you can change your backend, so that could be useful for development, or you might want to keep your options open in general. Yeah, and there's a whole host of backends for all the other main languages. And Honza at the front is he's working on a new Python, sort of a new official Python library. And so we're promised that at some point. Yeah, and I seem to have completely rattled through this and probably forgotten something, but yeah, I guess I can move on to questions, or I can sort of talk on a bit more about our experiences and what we do.
Yeah, thank you. Yeah, we have about 15 minutes for questions, so.
Hi, thank you. I have a question about Lucene and Elasticsearch. Every time I got asked about Elasticsearch, I couldn't tell the difference between Elasticsearch and Lucene. I understand that Elasticsearch is based on Lucene somehow, but I just don't grok the difference.
Okay, so the best way to think about Lucene is it's a library. and Elasticsearch is the actual service that you run. So Elasticsearch uses Lucene it is a Java library, so it just uses it like a Java library, and it then manages multiple Lucenes and specifically manages the clustering and the nodes and the scaling up.
So it's Elasticsearch that provides the REST API and stuff?
Yeah, so Elasticsearch provides all the API and also adds it's actually quite hard to tell where the lines stop, because unless you know Lucene very intimately, but yeah, so Lucene is what's used by Solr and a whole bunch of other things, but basically is just the library which powers the search in the reverse index, and then Elasticsearch is the service on top of it.
So basically you could also wrap around with Whoosh or other libraries?
Yeah, presumably.
When you were looking for your full stack search or whatever, did you look at Solr or Sphinx or anything else, or was Elasticsearch just your first choice of your company?
This actually predates me at the company slightly, but we've been doing search for, hosted search for about 10 years or so, actually possibly longer, I can't quite remember when they started. And originally they were using a proprietary solution, but then we moved to Solr, and we've been using that for quite a number of years. The main reason we then switched over to Elasticsearch was due to the need for clustering and scaling up to a larger index. And that was quite tricky with Solr, because you had to do it manually, and you've got to know a lot about clustering. There's a lot of problems and pitfalls in there. But yeah, Elasticsearch had it from the ground built in, and it's also Elasticsearch is a lot easier to use just in general, like configuring and so on. It's just a lot nicer. So almost everything can be configured with the REST API. There's almost no need to ever do config files. You can do them, and I think that's recommended for the schema, but we tend to just use the API. So yeah, that's the main reason. Easier and just a more modern approach to clustering.
How do you debug performance issues, or do you have a query analyzer or stuff like this?
Okay, yeah, so there's the I think it's _analyze as another API endpoint, which you can then, is that right?
So the analyze API does something different. The analyze API gives you the result of the analyzer. There is an explain that will actually tell you what the query will do.
Yeah. So it's explained. It's much like in other databases like MySQL and whatnot.
What could be the reasons for the health going yellow, and what are possible measures to make it healthy again?
Okay. So yeah, this is actually, I completely forgot to say more about that. So if you have a network partition, you can say you've got a cluster of 5 nodes and you lose 2 of them. Based on your replication, you should have everything on at least 2. So then hopefully you've not lost both of the ones with the same data. So suddenly you have 3 left, say, with all of your data, but it's not properly replicated. So if you lose 1 more, then you're at risk of losing your data for real. So the way to solve that is you can either, you can solve your network partition, get those instances back into the cluster, or you can add new instances. And Elasticsearch will also reshuffle the data at the same time, so assuming there's enough space and everything, then it will re-replicate it across the remaining nodes. So it will try and recover from that itself. And so if your cluster goes red, then I think at that point that's when you want to, unless you can bring back the nodes yourself manually, then you probably have to restore from a backup.
Hi, you mentioned that for your canonical storage, don't use the database itself, but something else.
Yep.
When I want to index a large bunch of HTML files, for instance,
yep.
What would you recommend as a storage?
Okay, so we use MongoDB, and that works fine most of the time. But really, you could use any relational database. Quite often, people are adding Elasticsearch to a project that already exists, so you'll just use it with whichever database you're currently using. I don't think there's any particular one that matches up well. And to explain why we would have a canonical store as well is allowing you to re-index, as I said earlier. It keeps you flexible, but also when we had issues like with the out of memory, you don't want to have to manually restart your your index, or with the you always want to be able to. Oh, what am I trying to say? Yeah, so it just keeps it a lot more flexible, and if you need to change the mapping, then it's a lot easier, because you can change the mapping and sort of re-index back into Elasticsearch, and that can be quite awkward. So that's sort of like schema migrations or changing data. And typically, your data, you might have some sort of transactional aspect or locking that you want to make sure, so sort of like consistency, but you can't do that so easily in Elasticsearch.
When you, if you have Elasticsearch reshuffle everything, I know it uses versions instead of locking to kind of check how fresh the data is.
Yep.
Do your version numbers often change if you're in yellow and you're like, oh, okay, we should kind of do a reshuffle and a recheck and reindex things? Do you notice the version numbers change when that happens, or not really?
No, I've not noticed that.
Hi, so Elasticsearch could build my indexes for me and stuff. Does it also support custom scoring and custom tokenization like Lucene does? Yes,
it does. Yeah, I mean, it's quite. There's a lot involved in that. Really, it's quite hard to fit in my talk. Although, with the speed I went through everything, I probably could have added something in. Yeah, it's quite hard to describe. So it's probably something I could show you after. Or there's a help desk on Thursday, and also Hans is doing a talk on Friday at some point. So there's some more Elasticsearch stuff coming up this week if there are more questions.
Okay, perfect. So thank you. And
thank you.
So I think the next talk should be about